Alright, welcome to our volume level 4 video, and in this video we're going to exclusively deal with how do you find the volume of a hexagonal prism. In our example 1, we're going to deal with an example hexagonal prism where we're actually given the apothem. That's going to be very important. But first, as always, when given one of these 3D solids, well, we want to shade the base. And remember, our base is not necessarily the bottom of the shape. It's always going to be the shape that we see twice. And if you'll notice right here, I have a hexagon on the front, and I have a hexagon on the back. And so since we have two of these, it's called a hexagonal prism, and so we know that that's going to be the base. Let me kind of clear that line out there. Oops. Okay, so let's go ahead and shade all this in. Shade, 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 shade. And why do I want to shade the base? Well, it's because the formula for volume is the area of the base times the height. Now, let's go ahead, and I kind of want to start doing these long substitutions like I did in video 3. And so what I'm going to write is I'm going to say this. I'm going to say the volume is equal to 1/2 the apothem times the capital P. Remember, that stands for the perimeter. And this is our formula for the area of a regular polygon. That's how we use our hexagon. And then times, of course, the height. And guys, I get that H just from right there. Now let's go ahead and plug in everything we know. And so the volume is, and I always want to change my 1/2 into a 0.5. Very good. So I'll write 0.5 times. We know our apothem is going to be 8. And once again, I get that apothem. It's just this line that drops down from the center to the midpoint of the base times the perimeter. Now this one's probably the trickiest part of this. We see our side here is 9, and we have 1, 2, 3, 4, 5, 6 sides. And so, hey, we're going to say, what is 6 times 9? We know that that is 54 centimeters, and that's where we get the perimeter, 54 times. And lastly, we know that the height is always going to be this one number that has nothing to do with the base. And so in this case, that's going to be 12. Now, as you look at this, these are some pretty big numbers. So we want to go ahead and turn to our calculator. And just pulling up my calculator, let's go ahead and type in. We have 0.5 times 8 times 54 times 12. And if you type this in correctly, you should get this number, 2,592. And because our units are in inches, we want to go ahead and write inches cubed. Don't ever forget, our volume will always be in units cubed. All right, now that's kind of our easy example. Let me go ahead and pause the video if you have to in order to finish writing down these notes. But let me go ahead and move on to our example 2. All right, so let's go ahead and write out example 2. Kind of use the inverse color here. So we'll start out with blue and then switch to a more vibrant red or orange. And let me go ahead and abbreviate this second problem as always. And I want y'all to find the capital V, which will stand for our volume. Now what's going to be a little bit more different, or a little bit different in this hexagonal prism, is we're actually not going to know the apothem. And so this problem will seem like quite a bit at first, but really and truly, once you get the hang of these problems, they're pretty simple. But let me go ahead and finish drawing my hexagonal prism. We know all these lines that I'm drawing, well, we could see them. We couldn't see that one, and we definitely couldn't see that one. All right, so we have this, and let me go ahead and say this side is going to be 8 centimeters, and this, aka the height, is going to be, let's say, 12 centimeters. All right, step 1. Remember, with any 3D solid, our first step, we always want to shade the base. Let me go ahead and switch to a nicer color. Yeah, I like this. Kind of like this UT Longhorn, almost burnt orange. Personally, this is kind of my favorite color combo so far, but if you like other colors that I've used in other videos, go ahead and drop a link or a comment below and let me know what you like more. All right. So we have our formula for the volume of a hexagonal prism, or any prism in general, is going to be the area of the base times the height. The problem is whenever you're finding the area of the base for any regular polygon, it's going to always be this: 1/2 times the apothem times the perimeter times the height. And I'm going to rewrite this kind of slanted off here so it's off to the side. But we always want to change our 1/2 into 0.5 times our apothem. And we actually don't know our apothem right now. It's not given to us. We're going to have to find that. We can find our perimeter. Let's see our perimeter. If this side is 8, and there's 1, 2, 3, 4, 5, 6 sides, we can just do 8 times 6, which would give us, 48. Okay. Let me go ahead and draw that just a little bit nicer and neater. And in fact, I'm going to move this over so I have more space because I don't want this to be sloppy. Okay, we'll just say, hey, we have our volume is equal to 0.5 times the apothem, we don't know that, times. We said our perimeter was 8 times 6, so that's going to be 48 times. And once again, we know the height will always be this line that has nothing to do with the base, so times 12. So it seems like we're just so close to being done with this problem if only we knew what the apothem was. And that's where we're going to have to really do a little bit of math. So here's what I'm going to start by doing. I'm going to draw my center, and I always want to break up my regular polygon into an equal number of triangles by drawing lines from the center to each vertice. And once again, we know from other videos, those are called the radii. Now, if you were to go all the way around the center, you would have a circle that's 360 degrees. So we're going to do 360 divided by the number of triangles, 1, 2, 3, 4, 5, 6. And let's see, what is 360 divided by 6? Well, that's going to be, that's going to be 60 degrees. Okay. Now, this is the part where people really, I think, struggle the most. And let me go ahead, I'm going to use a completely different color. Let me kind of use this fuchsia. I think that's what you'd call it. And we're going to drop our apothem. Now, the apothem always goes from the center. It drops straight down to the midpoint. And when we drop our apothem, it's always going to divide one of these triangles up into a right triangle. And so the whole purpose of dividing up our regular polygon into triangles is so we can actually get this right triangle. And so I always want you to draw this right triangle separately. So I'm going to draw that right there. Now, here's the thing about the apothem, and I want you to make a karate chopping motion with your hand. The apothem, it cuts things in half, and as I say, it cuts things in half. Do a little karate chop, all right? So the apothem, it cuts things in half. So that means it's going to cut our angle, our 60-degree angle, in 2, and 60 divided by 2 is going to give us 30 degrees. We also know that this base here was 8, and so the apothem cuts it in half. Do my little karate chop, and half of 8 is going to give us 4 centimeters. Now, I always want to write an X right there because, once again, that is our apothem. So this will always follow the same route. We know we want to use our tangent function, and so we say tangent theta is equal to the opposite over the adjacent. And look, if this seems like a lot, then I really encourage you to watch my area of a regular polygon series, level 1 through 4. You'll find out how easy this really is once you get the practice. So we'll say, okay, we have our tangent, and our theta is this angle. So that's going to be tangent 30 is equal to. Our opposite is always this side that does not touch the angle. So the 30 is way up here. We have this side not touching it. So we have this fraction 4 divided by our adjacent side, which will be x. Now, thinking back to previous examples, we always know that in order to get, with these trig functions, our first step, we always multiply by what's in the denominator, the bottom of the fraction. So I multiply both sides times x. Now that's going to give us x tangent of 30, our x's cancel, equal 4. And last but not least, to get the x by itself, we want to divide by the tangent of 30. So I'll divide by the tangent of 30. Man, that was sloppy. And if you type that into your calculator, 4 divided by the tangent of 30, let me go ahead and do that. We know that we're going to get our apothem. Okay, so let's see. We got 4 divided by, type in tangent of 30. And yes, that's going to give us this side x right here is 6.93. 6.93. And in this case, that would be centimeters. Now, I know this took up a lot of room, but this is so nice because now we can go back up in here and we can write in 6.93. Once again, what is that? That is our apothem. Okay? And now all we have to do is go to our calculator, type in those numbers right there. And you know what? Let me even switch back to kind of my burnt orange for this. So we got our volume here is going to equal 2. I go back to my calculator. Let me clear everything out. And I'll say, okay, so 0.5 times our apothem, which was 6.93, times the perimeter, which is 48, the perimeter of the base, times the height of the whole shape, 12. And that's going to give us, oh, big number. It's going to be 1,995.84. And don't ever forget, when finding the volume, it's going to be our units cubed. All right. And I know that's ridiculous. What is that? That's just a V for volume. All right. Well, take your time with this one. You only have one example on this page. If you need help, let me know. But good luck.